Good morning, all you PBI people. This is a lesson dealing with um, section 2 in electricity circuits. Um, Before I get into the lesson, I want to encourage you to look at my notes that I insert into your Google Docs as you submit your assignments to see where you need to make corrections or additions to your notes in your lab notebook. I'm also including complete notes on various days. So always look to see what I've added to the answers to the various questions in your lab notebook. Here we have three circuits. We have a single bulb circuit right here and two bulbs in series here. And we know they're in series because as we follow the electricity, we can go with an unbroken path from one side of the battery to the other side of the battery. And so we have a loop that goes through both bulbs and comes back to the battery. Then we have a parallel circuit. And when you have a parallel circuit, you'll notice when I get to this point right here, I can't go in a continuous line through both bulbs. I have one line that goes through here and completes a loop. And that looks just like a single bulb circuit. And then I have a second one that goes through here. Oops, it goes up here and comes back. So a parallel circuit, you have alternative branches that the electricity can go through. In the series circuit, you have just one pathway that the current goes through. Now, when we look at the brightness of the bulbs, you'll notice that these three bulbs are exactly the same brightness. And one of our assumptions that we were given in the lab notebook was brightness indicates current. So all three of these bulbs have exactly the same amount of current going through them. Now, a lot of you are talking about energy and voltage and different things like that. What we want to do is we want to just connect brightness of bulbs to current at this stage. So when you're answering the questions, always refer to it as the amount of current. Now, some of you have talked about amperage, and current is measured in amps. And so if you talk about amps and amperage, that's fine. So these three bulbs have exactly the same brightness. But if we look at this bulb, it is half as bright as this one. Now, when you're using your circuit construction kits, you'll know it's half as bright for two reasons. One, the lines are half as long. Two, if you count the lines leaving the bulb, there's half as many lines here as there is here. And so the virtual circuit construction kit is trying to show you brightness by the number of lines and the length of the line. Now, so they have half the brightness, they'll have half the current. Now, as the current leaves this battery, it has to go through this bulb and then through this bulb. It has nowhere else to go. So all the current here is the same as the current here, 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 and here. So the current is the same everywhere along the same line. No current gets used up. So why are these bulbs half as bright as this bulb? I have a little analogy that I like to use, and with the analogy, I have, and no analogy is perfect, so this is just something to try to help you understand this. So what we have is a dam in my little picture here with a lake behind it, and we have a hole in the dam, and that represents The dam represents the battery, and the hole represents the light bulbs. So this is a single bulb example here. We have a dam with one hole in it, and it's letting this much water through the hole. When we put bulbs in series, what we're doing is we're partially blocking this hole. And so if we put two bulbs in series, it's as though this hole is half as big as this one. So this one has half the size of this one. So it's going to let half the amount of water through. If we put a third bulb in here, then this hole would be 1/3 the size, and it only let 1/3 of the water come through. If we put four bulbs in here, this hole would be 1/4 the size of the single bulb hole, and it would only let 1/4 the water through. So when we put bulbs in series, what we're doing is we are restricting the amount of water that can come through. In electricity, it's called resistance. So as we add bulbs in series, we're adding more and more resistance to the flow of current. So we end up with less current. When we put bulbs in parallel, it's like we're adding another hole to the dam. And so here we have the original single bulb. Now we've put a second bulb in parallel to the first one. We've added a second hole. And so now we have two holes the same size, letting the same amount of water through. So we've doubled the amount of water that's coming through the dam. So when we go back up here, this light bulb has a direct connection to both sides of the battery. You might not see it to begin with. Get this to move down a little bit. When we look at the parallel circuit, this bulb here has a direct connection back to the battery. Now that direct connection means it's either physically touching the battery, or there's a wire going from the light bulb to the battery. Whether there's a wire there or not, it's considered a direct connection because it does not have to go through another light bulb to get to the battery. And so this is like two holes letting the current through, and each hole is the same size as a single bulb. And so we get just as much electricity coming through this light bulb as we do this light bulb, which means the battery has twice as much current going through it. So each bulb has the same current, but the battery has twice the current because these currents come back together going into the battery. When we look at the series circuit, neither light bulb has both ends with a direct connection. This bulb has a direct connection going that way, but when we start from the other side, it doesn't have a direct connection. It has to go through the other light bulb. And so whenever you don't have a direct connection on both sides of a light bulb, then it has to be in series to something. And again, when they're in series, it's adding more resistance to the current, more resistance to current. Therefore, we get less current. Two bulbs, half the current. Three bulbs, 1/3 the current. Four bulbs would be 1/4 the current, and so on. I hope this lesson has been helpful to you, and I hope it's clarified some of the things about current. The current is not being split here. All the current goes through this first bulb and all the current goes through the second bulb. It's just reducing the amount of current that's there. All right, we'll talk to you later.